Hey, Peter.
Angus back from vacay. Nice. All right, here we
Where,
go. Looking relaxed.
where were you?
The Smoky Mountains up in eastern Tennessee.
Nice.
Nice. All right.
All right.
So let's see here.
Yeah, why don't you try to do the share thing and see if you can get that rolling.
All right. So
Yeah, perfect. And you want to just press play and let's see if we get a full screen.
oh boy, let's see. I can't see what you're seeing though for some reason.
Can you go down? Are you seeing a full screen on your screen?
So how about now?
Oh, there you go. That's
Yeah,
good. That's good. That's good. Yeah.
We're seeing
Okay.
it.
Perfect.
So
Okay, so
let's talk about
let
this.
me-
I've got two things I want to show you.
Okay, hold on. Before you start, I got to give you an intro. Come on, you're
Oh,
like
yeah,
a special guest. Okay, and I'll start and I'll let Paul finish. But so welcome everybody to 1101. We are recording, and many of us are coming from different parts of the world, which is good. I see some people on from different parts of the country, which is great. And just so you know, Rob, we have people listening from city of Miami who are super interested in potentially joining the study. So, you have some people excited about what you're going to talk about. But for everyone's knowledge, those who don't know, Dr. Dunne, he's an associate professor at the Department of Emergency Medicine at Wayne State University in Detroit, of course. He's the fellowship director for the EMS Fellowship. And he's been talking about this device since last year, and we're all super excited about it. Those of us who, care and love the topic of stroke are really interested in this. But Paul, I was hoping maybe you could talk about a special award that Rob got this year, and then we'll let Rob start after you're done.
Oh yeah, sure. So let me turn this around. See me better. Yeah. So first of all, Rob is just one of my favorite people, literally. Not only on the doctor end, because he came in and took a city that really was in really poor shape for decades, and really did a good job despite all the odds against them for a lot of sociological, political, and whatever reasons, socioeconomic reasons. Has done a fantastic job there with a just incredible heart. He's one of the most generous and one of the most just delightful human beings I know, and just really smart at his job and just get stuff done. That they recognize that in the city this past year, and they made him not just the medical director for EMS, in the fire department, but for multiple city agencies, which stayed through COVID because he was doing such a good job. No good deed goes unpunished, and I won't list them all, but needless to say. But what I'm getting at is this past year, the Eagles, the Municipal Metropolitan EMS Medical Directors, awarded him what we call internally our highest award, because it's a reflection about the person we emulate the most in terms of being a medical director. And he won the Michael K. Kopis Award this past year, and we're just really it was just perfect for him. He's great and well deserving. And so you're gonna find out for yourself a good example of why I'm saying that. And I'm sorry to get too long-winded, but I feel to some extent actually trivializing an incredible career by this short introduction. So, all right. Well, thanks a lot then.
Thanks, Paul. All right, Rob, take it away.
Yeah. All right. Thanks, Paul, for the big build up there. All right. So let's talk about stroke, right? We all work in systems generally where we see a fair amount of stroke. I certainly know something about your demographics, and I've heard Peter's presentations. He also mentioned there was the folks from Miami. I want to give them a shout out, and we need to have a separate conversation about where you're going after safety pad, because we haven't figured that out yet either. But we have participated in a number of different stroke trials. Our EMS system was actually integral to the original NINDS trial. I was a resident at the time, and I spent my time training our EMS personnel to do an NIH stroke scale, because that's how we did the inclusion criteria during NINDS back in the 90s. And we've all gone through a lot of different things since then, right? And what we've done is we've seen that move from thrombolytics into thrombectomy and better outcomes for the people who have some of the worst strokes. and identifying the LVO. And I'm aware of some of the work that's gone on in your area, really refining some of the scales and having some very active interventionalists who support what's going on in EMS to get the patients to the best care in the fastest time. So we had been looking at some other options, some non-scale type options, and we do a lot of technology research. We have kind of a technology incubator at our university that works closely with the medical school, and actually one of our own emergency medicine docs, Jim Paxton, who some of you may know, I think he ran the ASAP scientific forum this year, the research forum. And he had been very involved in some of this technology to try and identify early on a large vessel occlusion using some technology. So, we all know we want to get some of this identified. We want to get identified right. Maybe a little over triage is fine, but we don't want a ton of over triage, especially since it may mean patients moving a long distance for little or no benefit. So originally, you can see this device, and when we break off, I'll show you. I've got both the devices here, which is handy. This was our prototype device. These are still experimental devices. This was used in a fixed operation at hospital triage to determine large vessel occlusion and large vessel stroke and develop some predictive modeling. It uses incredibly sensitive accelerometers to detect the flow of blood in your brain from various different points on your skull as a headband. And of course, what really makes it work is the processing that is going on behind the scenes to interpret that data, right? These are very small signals. So getting rid of noise, figuring out what it means, and interpreting it. So a lot of that kind of derivation set happened before we got into our trial. This trial from Smith 2020 was done at a stroke center where they were really looking at how well this device worked. And at the time, this device interfaced with an iPhone, where you put in some questions and then it gave you some probability of large vessel occlusion, and had a capability of doing some mapping. It's no secret that the company that makes the device is located in Cupertino, with those who will not be named. And then we had these results from that. So this stroke device is the first column on here, showing this red line is the false negative, the blue is the accuracy. So you've got accuracy over here, you've got false negative over here, so don't get hung up on it. So it was 92.6% accurate with a 2.9% false negative rate, which gives you a false negative rate a little higher than a race of greater than or equal to 5, but a little more accuracy as well. There are ongoing fixed trials on this to continue to refine this as the technology has gotten better, but they were interested in the proof of concept about whether this could actually work in the pre-hospital environment where there's a lot of vibration and noise. And obviously we all know it's a lot different than sitting in an exam room or a triage room. Even as chaotic as your triage area may be, it's not the same as the ambulance, and particularly for something that's trying to sense very small signals. So working with Dr. Paxton at our site, they reached out to us in Detroit to do a clinical trial. And I want to talk briefly about the clinical trial, and I'm going to jump to the slide, a little more updated slide deck. The way clinical trials work in EMS in our state, we have these things called medical control authorities, which were the state basically drew a map, and if your patients came from that map, the hospitals had to get together and they had to create a board that had to write protocols, had to give all the drugs to EMS and not charge them, had to set up quality improvement, was responsible for all the EMS data, and really this giant unfunded mandate that has some pluses and some minuses, of course, like all of our EMS systems. But when they did that, they also created a portion of the state law covering pre-hospital research, which in many ways has helped us to facilitate pre-hospital research in Michigan, which is something that we've all been pretty enthusiastic about with kind of the blessing of the state. So it's a multi-step process, of course. The first thing we had to do was, come up with a research protocol. We ran that through our Wayne State IRB, and we had to create an EMS protocol. The EMS protocol that goes with the research and that initial IRB approval is what goes to the state, and then the state blesses that as what's called a study protocol, and then all of the agencies within your geography can then participate in the trial. And that trial was basically to put the stroke headband on anybody who had, positive signs of stroke or significant altered mental status. And the left side of this slide is the protocol, which I'm also happy to share. So you suspect it, you open the app, you put the headset on, and then you transport the destination hospital. We then consent the patient to have their data included. This was fine with our IRB because this is a minimal risk device. It just is a headband that passively sits on your head. It only has to sit there for about a minute. And then you can choose whether or not you want your data included in the trial. And our consent through rate has been, over 96%. We've had a couple people that did refuse, and then we have had a couple people that had other things going on that prevented them from consenting, and we had no next of kin. And of course, as many of you are familiar with, we had some patients who just walked out of the emergency department before any other workup was done, despite their high concern for stroke. So nothing I could really do about those folks. And that kind of sets the stage. Here, let me move to this other set of slides, and then we can do some Q&A, and I can show you some hands-on. So can you see a different slide now?
Yes, perfect. Yeah.
Perfect. Okay, so let's just jump ahead. That's where we left off. That was the old device. We moved to a new device about 5-6 weeks ago. This is much closer to a production looking device, and I'll hold it up, but I want to show you a couple of things on it. You don't see the exposed electronics. Patients kind of like it when it looks a little better, as do the medics. And then it doesn't use an iPhone anymore. It has a built-in screen with some navigation buttons on it that does the work. So for us, for this trial, we're blinded to the LVO determination, right? That is, this is truly the validation of the concept that we're going to take the clinical data and adjudicate that, and then the data from the headband, and we have an independent review board that's putting that data together to say, does the prediction from the device match what we're really seeing in our patients? We've got a bunch of different agencies now involved, including some Bay Area agencies in California, West Michigan, based out of Kalamazoo, and our Detroit regional area, both public and private agencies involved. This was as of a week ago, we had 223 enrollments in this phase of the trial. We launched the new platform May 10th in West Michigan and May 30th in Detroit. We had interim data analysis. So the interim data analysis says, yes, we're good to continue, and we're good to expand the trial, basically making it sound like, without knowing what the actual unblinded data analysis is, that it seems to have an accuracy that looked similar to what was in the hospital data. And we had 11% total LVOs. So that means we had enough like true positives in our actual clinical data to probably be pretty meaningful. And this really gets us to where we are today. You can see this this enrollment. This is going to basically get us through this first phase, and then our goal is to get at least 400 subjects in the next phase using just the new device in a bit more sophisticated clinical trial, which is how we were kind of talking about looking for some potential sites. And you know, if people are interested, you can certainly reach out to me. We don't have a site questionnaire finished yet, but we will get those out, and then we'll look at them. Obviously, we're looking for places that have a fairly high frequency of stroke, because we think with the right set of sites, we could get to the 400 patients fairly quickly. We have a fair amount of strokes in Detroit, but you can see, you know, during some of the worst of the pandemic times, we had some challenges. That enrollment has really gotten better. Some of that is getting the word out. Some of that is the fact that we opened up more sites. But I think just with a few core sites that have a pretty good data on how many LVOs they see now, we could probably do the second phase of the trial a lot more quickly. So let me get out of this and all right, so you shouldn't see sharing now.
Right. We don't see sharing. Yep.
Okay, good. All right, so I have both the devices here. The original kind of more, you know, this is more like Terminator 1, you know, the first device. And this is more like T2, right? You know, a little smoother. All the electronics are hidden on the inside. It does do a cardiac. It does track your cardiac activity, because it's got to match that to the accelerometer, so it knows where you are in the cardiac phase. And the processing technology that's now in this device is a bit more sophisticated and completely focused on the trial rather than having to do an app on an iPhone. The other thing we did run into with the iPhone-based device is that despite the fact that we had these iPhones pretty much locked down off, is that, you know, in the environment, it's a little chillier up here than where you guys are. Our battery life in these was not what was expected. So we occasionally had dead devices, which of course meant that was an enrollment that didn't work. This has a much more simple battery in it, and even in our environment should last for at least a year without any drainage, because it's not really doing anything until you turn it on. So I'm happy to take questions. I don't know where you want to go with this.
I'm sure you're gonna have a lot of questions.
Model the device, you know.
There you go.
Kind of nice.
So Rob, I mean, this is so exciting. Obviously, many of us struggle with quantitative stroke scales. Other people use, you know, the non-quantitative, the VAN, and there's some big fans of the VAN and FAST-ED here and other stroke scales. And obviously, what we struggle with is the constant education that we have to put out to our troops. Do you think that this would kind of obviate the need to teach that anymore? It's just basically throw the headband on. Again, this is if the studies prove their worth. You just kind of throw it on, and then the output on that little white device there will tell you kind of yes or no. Is that how this is going to look?
It's going to tell you a percentage chance, basically, right now. That's how it is. Now, obviously, part of the next phase of it is to get some feedback from users about what they want, right? You know, I think most accurately reflecting what testing really is. Testing's modifying pretest probability to post-test probability, right? So having that is probably the cleanest way to do it, by putting a percentage on it. And we kind of know that for things like race, right? That it's predicting the chance of LVO, and it's, you know, and it's doing a pretty good job at, particularly when it's high. And I think that most people are pretty comfortable with that as a concept in stroke, But yeah, I mean, there is the pretest probability, right? We're not just like putting it on everyone, just like we don't do an EKG on everyone. We have a fairly broad criteria, right? But it could be just a very simple criteria of, any kind of, going back to some of our original simple stroke scales, a Cincinnati or a BFAST or however you want to talk about it, to say, if the person has altered mental status, because I do want to include that, right? The worst LVOs sometimes look like something else. And that's where I think sometimes the patients that we can't accurately do a race or even an NIH, it's just all high. Some of those turn out to be postictal or metabolic encephalopathy or something else, that this device is particularly good for those. And we often know that some of those are the ones that we miss at the hospital for a while. We're goofing around doing other stuff, and it turns out they've got, you find an LVO a little bit later in their workup, and God forbid, maybe you figure it out too late, that person who's intoxicated and you're blaming the alcohol when they actually had a stroke, but they can't participate in doing a race. So this gives you, again, like a way an EKG would, it gives you some more information. And again, its preliminary data looks quite good, looks better than any of our scales, and works on some people that our scales don't work on.
Do you have any idea of the false positive rate? Oh, sorry, Paul. The false positive rate thus far on this with this device, because obviously you have people on this call who are rural, right? And they're going to be needing. They struggle today with: do I take the patient a mile away, or do I land a helicopter? Paul Banerjee, who's really started with stroke way before all of us have. He's that guy, right? He has to fly people out. So do you have an idea of the false positive rate on this device?
Not clearly, because we haven't unblinded the data from this. If it looks like the fixed-based early generation device, which I honestly think it'll be a little better, it was biased towards over triage a little bit. It had about a 15% over triage rate. So if you want to kind of consider that in your false, as part of the false positive, it is biased a little bit towards over triage, in terms of, and that's how you write the algorithm, right?
Right.
If there's things in it that make the device think there could be an LVO, it's got a reading that it's not sure how to interpret, then it's going to say it's concerned.
Yeah.
Whereas their CTA may show something different, or may show some diffuse disease, right? But I think that the design of it is to have a bit of over triage in it.
Dr. Pepe.
So my question was kind of on because your question was really appreciated, Peter, because of the issues, like you said, for the people out there at a distance, although the volume may be lower out there. What I'm more concerned about, are we missing anything? So the issue is going to be the sensitivity thing that we'd be looking at here. But you don't have any, in other words, did you miss anything because of it? That's the main thing that would always bother me, the most, right?
Sure. And again, the best data on the false negatives is that it was about 1.5%. But again, we'll have a lot more when we unblind this data set.
And so it would be interesting to compare it to the different scales we have. And also, but if you had multiple tools at once, including this, do they improve your probability as well? So that's another thought. So
absolutely. And that, again, I think I showed the fixed that slide from that fixed trial, and I can just put that up again just for a quick second. And we could get into a tiny bit of detail on this. This was done at triage. Can you guys see this?
Yeah.
This is the first column is the headband. The blue is the accuracy. In this they had a 2.9% false negative rate. These are various stroke scales. FAST-DD, GFAST, the NIH stroke scale, the VAN, the RACE, the PASS, you name it on here. And you can see in the, composite accuracy was relatively relatively high. The false negative rate, which is this red line, was not as good as an NIH of greater than 6 or a race greater than 5, but similar to the kind of next tier of things, and way better than some of the group. But
Sure.
again, this was only 68 patients, and it was done in nearly an ideal environment, but not perfect environment. So I think that was what made us really interested in doing this.
Well, it's
Right.
fantastic. All I could say.
Yeah. So Rob, I just want to we only have 5 minutes left, but I'm sure people here who are looking at this saying, Mimi, I'm going to raise my hand, my agency, please. So can you give us a few minutes on how that would look? What would be required from us?
Yeah. So any agencies that are interested, you obviously can share my contact information. And it would involve a questionnaire asking particularly about numbers. Number of stroke patients evaluated, some sense of your percentage of LVOs, what you're doing now to identify those, and what your and a little bit just about your experience participating in clinical trials.
Perfect. Okay. Well, we have some people on the call today who are part of the Florida Stroke Registry. University of Miami has done an incredible job. We now have a beautiful registry that hospitals participate in, EMS medical directors can view. So we I think are, and we're God's waiting room. So I think we are the perfect blend for you.
Well, I think you guys are too. I mean, I've seen your data, and you actually came up here and presented it in Southeastern Michigan at least once. Yeah, absolutely. I think that the Florida community, urban, suburban, moderate cities, you guys have very high incidence of stroke and a fairly high incidence of LVOs as well.
But this also goes to the registry, Peters, that our studies that we did that showed the issue wasn't so much getting someone to a trauma center quickly. I mean, a stroke center quickly. It was getting people to recognize the stroke, at home. So we got to combine those programs as well. You could have the most high-powered tools or whatever else is that you don't get to the patients to give you a call. That's an important part. I think that should go hand in hand here as part of what we do, outreach from our hospitals or whatever it may be, or comprehensive stroke centers, right? So.
Yep, 100%. Now,
by the way, we're doing that, but we got to come up with better mechanisms, and I'm just going to couple that creativeness with what we're doing here. And this is exciting. It really is good.
Dr. Gandia asked Rob if we can do multi-agency. So, in Broward and not so much in Miami or Palm Beach County, but we have many different kind of smaller agencies where, you have Dr. Clift from City of Miami, larger agency. So is it that every agency just needs to participate in the IRB and then you can enroll smaller, larger? It doesn't matter how
absolutely.
that goes.
So, our med control authorities make that easy. We kind of have our whole med control authority participating in it, which is kind of like those STRACs in Texas or whatever, but with some legal framework on it. So yeah, we included all of the agencies.
And then let me see if I know Dr. Clift. Armando, are you there? I know you're sitting in a room full of people. Just initially, I was wondering to hear your thoughts and what you thought about this opportunity.
Yeah, I mean, it sounds really interesting. I guess it's just the logistics of how to implement it. If all the data is just going back to Dr. Dunne and they're handling it on that end, versus do we need the hospital research stroke coordinators on board, and does each destination that's a stroke center have to be separately enrolled in the trial, or how does that end of it work?
Yeah, so that's how we did it. Although most of our hospitals are Wayne State affiliated, so that was relatively easy. So they all kind of recognized the Wayne State IRB. Most of them had found that it was a pretty easy. I mean, it was expedited review at a few of them, because all you're doing is having a brief discussion with the patient about looking at the data that's already been obtained. But yes, you do need the if you will, the kind of proof of what happened to the patient, right? You need to, what was their end?
Right. Awesome. Great question, Armando. Dr. Pepe, go
You
ahead.
can reach out to me too, Armando. I'm happy to chat.
Okay.
Paul, you're
Sure
on mute.
will. Thanks.
Saying I'm heading over to Eagles. Your CME code for today is 15259. 15259 for this
Awesome.
call.
Awesome. And last question, Rob, because I know people are asking. I mean, is there any? I mean, it looks like it's reusable, right? Are there disposable, consumables, if you will? There's the device itself and consumables. Is that how this works? Or you don't
Right
know
now,
that
I
yet?
think the intent, it's still an investigational device, but right now the intent, I believe, is for it to be a non-reusable device.
Non-reusable device. Ay.
More like a pulse ox probe or something, that like a stick-on pulse ox probe, than something that you would reprocess. But that again, that's all in a FDA thing that hasn't been decided.
Right. Because if that's the case, the next question is going to be, what's the cost per unit?
Absolutely, and that has
You don't
been
know
to
that.
me there, and I've been actually trying to, the company has asked me a few questions about it because I'm not like one of their, their accelerometer scientists, but I certainly understand how EMS agencies work and how we buy things and stuff like that. To me, the market for this is the stroke center. The stroke center's got to love it and trust it, and they've got to be part of how we would get it into EMS units. I can tell you, like in my area, when we first did 12 lead transmission back in the early EKG for, STEMI PCI, that was all paid for by the STEMI centers. They're who bought the stuff for EMS, not the.
You end up having Stark law issues there, right? That hospital
Yeah,
A.
see, we don't, because it's all a safe
See.
harbor because of our med control authorities.
Right. Yeah. Here it's completely the opposite.
I know you guys have a completely different set of laws on things.
Here we have billboards with how much time it is to get to the waiting, in the waiting room. So, all right.
We used to have
that's
those, but nobody wants to have like 10 hours on them anymore.
right.
So
Well, listen, when you talk to the company, try and fight them a little bit back and say, listen, EMS, we obviously get paid a fixed. We're like we're on a fixed income. If you
I know I tried to explain that to them about how 911 works, right? They're like, well, you can just bill for it. I'm like, no. They're smart scientists, but they don't know anything about marketing.
Someone asked here, can this be modified to detect vasospasm?
Possibly it would be a similar thing. I think what would happen is vasospasm would trigger a positive, right? Because there's no flow. You'd have a no flow state. But that would have to be there was spasm at the time of the event.
Gotcha. All right. Well, this has been very, very fascinating. We look forward to seeing when this data is going to be, processed, and hopefully other agencies will reach out to you. Thank you so much for coming on
Thanks
today.
for the opportunity. I love talking to you guys. I always am impressed by what you're doing down there.
No, we appreciate it. We appreciate it, Rob. Thank you so much. And we're gonna move over to Dr. Pepe. So, Dr.
I'll
James,
be over
take
there in
us
a
away.
few minutes.
All right. We'll see you on the other side. Thanks, everyone.